looks like we're live on there. Awesome. Okay. Broadcasting to Twitch.
Confirmed on YouTube.
And it looks like we're live on Twitch. All right, I'm going to start the 5-minute countdown.
I'm kinda like complicated. I never
See us on
know
YouTube.
chase it.
And I see us on Twitch. Hi, everyone.
Hello.
If you follow my Instagram, you know that we have a special guest right here. We have Rev today. Thanks for joining us today, Rev.
Thank you for having me.
This is going to be a fun one. As you know, we don't often get to grab Rev's time, and we're going to be chatting on a few different things today. USD, MDL, but also we're going to touch on probably one of the hottest topics around right now, which is Metaverse and how we're thinking about things. So that'll be a lot of fun. We definitely want to get people's questions too for the contest. So we have the Extend Omniverse contest in progress right now. You still have until, I think, midnight on Friday night Pacific to submit. And we are really looking forward to people's extension to see what kind of creative things people came up with. It's a great time to ask questions. We have Maddie here, who everybody knows has been super helpful on Discord and the forums, along with Paul Cutsinger's and team, Jennifer and Ashley. So a lot of Eric, a lot of good support on Discord helping people with the contest. So you got us live right now. So if you have any questions, feel free. And since we're waiting for a few minutes before this thing kicks off, feel free to post your questions in the chat anytime you're ready. You're going to see the side of my head a lot on this one. I'm going to be checking the different chats. I see hello from Turkey. What's going on? Hello from India. Thank you for coming. Really excited to have everybody here. This is going to be a really fun episode. We got so much to talk about. GTC is coming up.
Oh, yes, GTC. I'm so excited. I cannot wait.
Right on the heels of SIGGRAPH, where we made some pretty amazing announcements about apps and updates to connectors or new connectors, as well as we also shared information about stuff that's in development. We have a great forum post on it. If you go to the Omniverse forums, SIGGRAPH announcements, so everything's kind of listed there one by one. And we broke it down by what's available now and what's coming soon. We always get a lot of constructive criticism, I'll say, after GTC and SIGGRAPH, because we have a tendency. This is such a hardworking team. We're always working to push the boundaries of everything, and we really like to be open and transparent when we're showing stuff in progress. But sometimes that can be pretty frustrating for the users. If you want to you see something that looks awesome, you want to dive into it, but it's not ready yet. So in the forum post, we kind of broke down what's available today, right now, and what's coming next, what the team's really working hard on to make available as soon as possible. And we actually are pretty good about releasing things as soon as they're ready. We don't sit on things. We try to get them out there in the wild as quick as we can to get feedback.
Your feedback is really important to us, so that's why we do that. And hello from UK. Hello to the UK, Manhattan Beach, New Jersey. It's 1 a.m. in India, so if you're from India, thank you for staying up late.
Super fans.
It's pretty impressive.
Super fans.
Okay, so the notification just went out on Discord, so we'll see a few people popping from Discord now. As we usually try to do, we're going to, at least some of us will be hopping onto the Discord community voice chat server following this live stream. So if you have any questions that weren't covered in live stream, or you just want to say hi, let us know how your work is going in Omniverse, pop into the voice chat. We'll hang out there. You can unmute yourself. It'll show you out. There's my Outlook reminder that we have a live stream starting. Thanks, Outlook.
That's one of the apps I always forget to close during a live stream. I'll hear the.
I'm afraid to
and
close
I'm like,
it.
Oh no! Be the professional. NVIDIA loves you.
I love this Brady Bunch moment where we're all in this windowed screen. Jan looks ready for action, although relaxed in a sense, but also ready to pounce.
Ready.
Where are you, Jan? Are you at the office?
No, no. Actually, I'm not even in Berlin. I'm in the north of Germany, on Rügen at the moment.
Okay.
Nice.
Is that a hotel you're in then, or?
No, it's a small apartment.
Okay.
Yeah. Hi everyone, welcome to today's live stream. We're going to be talking about USD and MDL. And we have a very special guest. So happy. Rev has joined us today. He is what we call Edmar, the godfather of Omniverse.
Father of the Omniverse is
Yeah.
my nickname for him. But yeah, anyone who's attended GTC or SIGGRAPH or watched some amazing interviews about Omniverse and NVIDIA, you're probably very familiar with Rev. And he will, I've often heard you say this, Rev, you will tell people that Omniverse has been in development since the start of NVIDIA in many ways. So thank you for joining us. That's not the only special guest. We actually have two other special guests here,
Yes.
one of which is on vacation right now. So Aaron, thank you for jumping in just off the plane. He wanted to hop in. He's gonna talk to us about USD, MDL. Jan is also going to talk to us today. We're going to have we're going to start off kind of quick announcements. Then we'll dive into the topic, which is Metaverse, USD, and MDL. So really excited to have him here. We want everyone to post your questions as you have them. We'll keep scrolling. We'll try not to miss any. But post your questions related to the topic we're talking about. Because we have Rev here, you can probably ask some stuff a little bit out of the range of the show, and we'll try to get to it. And then obviously let's just start by saying our contest right now in progress, Extend Omniverse. We are incredibly excited. This is our first developer contest. It is you have until Friday at midnight Pacific time to get in your submission. If you're having any questions, problems, roadblocks, you need any help, that's what we're here for. On the forums, Wendy is there night and day. We're on Discord. We have a bunch of developers that are standing by to help people, and we're already getting some sneak peeks at some extensions people are submitting. So definitely use this time to also ask your questions if you have one. We'll see what we can do. But I wanted to also to start off the show by saying to everybody that this is number 50. This is live stream number 50.
Oh.
I didn't even share this with Wendy. I gave Wendy a little video earlier. I told her not to watch it yet because I have to really take a moment to say how much I appreciate and I'm thankful for Wendy's involvement on the show.
Oh, no. Yeah.
Wendy, as anybody in the community knows, anyone who's watching who spent time on the forums knows, Wendy is the strongest advocate you have for anything you're working on Omniverse.
love you guys.
She will fight tooth and nail for anything people are asking for, really get into it with the devs to make sure that we're prioritizing helping people's questions. And as the work has evolved to include the live stream, she's done an amazing job with some really challenging technical problems we've had just making the live stream work as good as they do. It's actually not an easy thing to produce from a hardware and software perspective. And Wendy has hit every challenge with awesome energy.
Trial and error, right?
and just with positive, but it's always positive. So thank you. So Wendy, if I could ask you to play this small clip, these
Yes.
are some of the great Wendy moments from the past 50 streams.
Okay, yeah, and I have not seen this yet, so this is going to be fun. omnivores. We're back. Thanks for joining us today. Hello, everyone. Welcome to the stream today. We've got a really good show for you today. Without further ado, I'm Wendy, and welcome to today's live stream.
1, 2. Yeah. Right.
I can't even tell you how excited I am.
I didn't see Jasper, our Omniverse cat. He's probably on Instagram doing something.
He knocked down one of my lights during the stream, so if you saw my lighting change. He was sitting like right next to me this whole time, and I didn't even see him leave. He was just like, I'm done with that light. Take it out. And Brian and I, we were doing a lot of stuff with Blast, testing it out, making sure everything worked. That was the best part of my day. It just bringing in objects and just breaking them.
That's awesome.
We have with us today, and pardon my pronunciation, I did practice this, Universidad de Artes Digitales in Guadalajara, Mexico. I know that's awful, but
That's pretty good.
It was good.
I love these guys. These group of developers are so much fun, and I love having them on.
I can't look.
What? Oh. Oh my god, that looks so good. That's like my YouTube video search. Cats. Yay! Woo, I'm so glad I'm so glad you're able to join us. Now we're gonna look at Simon. Woo! The camera switched over. So Benny is actually joining us from Nigeria today.
Yeah.
Across the wide pond here.
Eric is not a figment of your imagination, even though his name is not in the footer of the stream. He is actually here. He's real.
And I think I spelled your name wrong too, Brian. I just failed on all points here.
Even if it's just playing, even just play around,
You
get
to the fun parts fast, which is that's the key, right? The Omniverse cat Jasper. You probably saw me having to mute my microphone. He
Did he pull down your blinds?
he pulled down my blinds.
I thought I heard that.
Yeah, the big crashing noise was him.
All right, thanks everybody.
Thank you for joining us.
you.
Thank you, everyone.
Bye.
Thanks.
Bye.
Hi guys.
Bye.
Oh my God, Mark.
So of course you can tell we have a lot of fun here, but the primary mission is always to educate, and Wendy does that with smiles and positivity every week. So thank you, Wendy.
Now I have to do one for you, Edmar.
No, okay. I don't have nearly as many good moments. But as you saw from that clip, obviously we've covered so many different things on this live stream. One thing we really haven't touched, which is awesome to have Rev here for this, is we really haven't touched the whole concept of the metaverse and how that plays into what Omniverse is and what NVIDIA is working on. So we're going to spend time talking about that, USD, MDL, but let's start with Rev. Rev, would you mind introducing yourself so people can hear in your own words kind of what you do at NVIDIA and tell us your take on Omniverse and metaverse?
Sure, and thank you for inviting me here. It's always really fun to talk to our community. My name's Rev Libridian. I lead the Omniverse and Simulation group here at NVIDIA. I've been at NVIDIA for 20 years, and I've been doing computer graphics since the mid 80s, when I was a kid. Last week was SIGGRAPH, and I think probably most of our viewers here know what that is, because you're probably a computer graphics enthusiast, or have some association or love for it, being here and as part of the Omniverse community. SIGGRAPH for us is almost a religious experience for people who are into computer graphics. It's the one time a year where we get to gather with everybody else who is passionate about this field of computer science, who's passionate about the intersection of art and creativity and computer science. This is where they meet. This SIGGRAPH, I think, was a really special one And I think we're going to look back at this particular year as being a pivotal one, where computer graphics, the market for it, the importance of it, grew and fundamentally changed in the world. My first SIGGRAPH was at such a pivotal year. It was in 1993. That was the same year I turned 18 years old. You guys can do the math. I'd been doing computer graphics for years, and I wanted to go to SIGGRAPH, but it was never in my town. It wasn't in Los Angeles until then. That was the first time it was in LA, and I happened to be 18, so I could just take myself. I didn't have to depend on my parents flying me out to whatever city it was in. That year was a really, really special year. Lots of things happened that year. That was the year Jurassic Park came out, and for those of us that are old enough to remember that moment, and if you were in computer graphics around that time, everything changed after Jurassic Park came out for people into computer graphics. For the first time, we had a large demand for our skills in computer graphics. There were some movies that had some computer graphics before that. There was Terminator 2, which was kind of a seminal film, and a few other things. Pixar had been they were doing commercials, like Listerine commercials and Lifesavers, and there were cool shorts and stuff they would put out there, but it was all kind of fringe niche stuff. But Jurassic Park fundamentally changed everything. From that moment on, for anybody who went to go see it in the movies, it was clear that we could never go back to the old way of creating those effects. Dinosaurs became a real thing all of a sudden, and there was no going back. And so that year at SIGGRAPH, you could feel it. It was like palpable. The energy there, it was huge. There was Silicon Graphics was the biggest company in computer graphics at the time, and they had this huge booth that was all Jurassic Park themed out, and the industry was formed around it. It's also the same year that NVIDIA was born, 1993. So it's a very important year for us in NVIDIA, and I think for computer graphics in general. If you think about it, we're probably the largest company that's invested in computer graphics. Fundamentally, what we do, it's in our core and our DNA. I don't think there's any other company at our scale that is as invested in computer graphics. And it's also the same year the World Wide Web came together. That's when it was born. And so the internet explosion started at the same time. And these three things kind of combined at that time to lead us to where we are today. All this talk about the metaverse, trying to define what it is and what it means, how it's going to change the future. Is it just hype or is it something that's going to be lasting and profound? Those are the same discussions we were having about the web and the internet that year, and 1994 especially is when it really started to explode right after. All of the same criticisms I'm hearing now about the metaverse and what it can deliver or not deliver were exactly the same things we said then. I remember.
So interesting.
People who knew something about the internet. I had actually managed to find the internet in the late 80s when I was a teenager. I found it so that I could go learn more about computer graphics. There's this guy at this university who had like an ASCII newsletter about ray tracing. His name is Eric Haynes. And I had managed to get my hands on one of those, and then I saw there was this weird internet address on there where you can get the rest of them. So I found my way onto the internet. Eric Haynes now works at NVIDIA. It's awesome. I got to tell him that he's one of the reasons I'm at NVIDIA and doing what I'm doing. But anybody who understood what the internet meant about the possibilities of connecting everyone around the world, we started, hypothesizing about the kinds of things you could do. Like maybe we'd be able to have a conversation like this with video chat with each other. seemed crazy at the time because the internet was just text. You know, you had a 2400 baud modem, you log into a Unix shell, and your interface was really simplistic and limited. But we could imagine that. We could imagine eventually you'd be able to click a button and stuff would show up at your house, like food and books and anything you might want to buy. And we said all of those things, and people actually tried to do it early on, but they failed, many of them. There were a lot of hyped up .com companies in the 90s. But eventually, we got all of those things, everything we theorized at that time, like it happened. They didn't all happen immediately, but over the decades, now we take it for granted. We just pull this thing out of our pocket and press a few buttons and all this magic happens. So it's important, I think, for everyone this time around to really pay attention to what's happening here with the metaverse. And don't just write it off as this hypey thing that requires special devices that we're going to put on our heads, and everyone has to buy one of these things before it starts becoming useful. What we saw with the internet as it expanded is that between the point where it started and where we are today, there were already really valuable things we could do every step of the way with it, and some things that were surprising to us. Immediately, I mean, just being able to email transformed everything, you know, to our businesses. Being able to do chat in our little chat apps, that changed everything. Putting government forms up on the internet. Wikipedia forming, you know, all of the world's information, the encyclopedia being crowdsourced. These are things that were useful even without having the most advanced tech, the more advanced tech that we've developed on top of the web after all these years. I believe we're there with the metaverse. We've spent the last 3 decades since Jurassic Park, and NVIDIA's forming that year. It's 29 years now. Advancing computer graphics and simulation, building full computing stacks so that we can do real-time simulations of virtual worlds, and all of the tooling around that to build that to get to the point we're at right now. And for the first time, since I've been doing computer graphics in the 80s, I feel like this dream that we had, my contemporaries at the time who read all the same books, William Gibson's books, Neil Stephenson's books, we finally have the beginnings of the technology, all the prerequisites necessary to form this metaverse thing. And when the question is asked, well, what are you going to do with the metaverse? What is it good for? How is it going to affect us? I think we should just look back at the internet and go, we were asking those same questions. And the answer is, well, there's a whole bunch of things we can imagine, but there's a whole bunch of things we don't know. And we're going to figure it out, because this is just a fundamentally profound thing. Being able to construct virtual worlds that humans and AIs can participate in and interact in the same way that we do in the real world, like using all of the sensory inputs that we have in the real world. That's just profound and super powerful. It's a powerful technology. Essentially, we can teleport with this thing. And so what we've been doing at NVIDIA all of these years is building the foundational tech for this, so that we can kind of build all of the plumbing and infrastructure that is going to be necessary to power this kind of thing. We think about the metaverse as essentially an evolution or an extension of the internet. Pre-web, the internet was all about text. It was still super powerful, being able to be, so real-time connected to anyone in the world that was on the internet, no matter where they were. But it was limited. It was limited. There was only a certain class of people that could go enjoy the internet then, because you had to know how to use Unix and essentially be a computer scientist or software engineer to interface with it. When we introduced the web, we made the internet accessible to more people. They could do more things with it because the interface became text and images, which with a graphical user interface, you can point and click and portal from one web page to the next. It was something that a large number of people in the world could do. Immediately, millions could now join the internet and make use of it. And decades later, here we have billions of people on it now. What we're doing with the metaverse is we're essentially overlaying a 3D interface, something that looks and feels more like the real world we're in is going to be the interface into to the internet. And what that's going to do is just expand the set of things we can do and make the experience more accessible to more humans, because it's going to start matching what the human experience has been since our evolution. We're going to feel like we're in spaces together, and we're going to be able to interact with each other using hand gestures and our facial expressions, and all of these things are going to be communicated in the same way they are when we're present in the same place. At SIGGRAPH, I participated in a course on the metaverse. There was a SIGGRAPH course on the open metaverse. And there are some amazing speakers there. All of them are amazing. And they all presented really interesting views into what the metaverse is. I don't know if those recordings are going to be available or what, but if you ever get a chance to see any of those speakers speak about it, I highly recommend it. For my talk, I tried to show a view of what the metaverse is and what it can be that's different than I think what we mostly hear about with the metaverse. If you think about how it's been presented to us, largely, it's been presented as a new entertainment medium, or maybe a social medium. Primarily, this is just like a place we're going to go hang out or play games together. And that's certainly true. We're definitely going to do a lot of that. The same way we already do that with the internet. People play games and socialize and communicate with each other on the internet. But that's not all the metaverse will be, in the same way that's not all that the internet is. We do a lot more than just socialize and play games on the internet. We use the internet as a foundation for how we work. We use it in our businesses and enterprises. We use the internet for communicating communications between groups of people who are building things. Whether you're building skyscrapers or cars or bridges or phones or whatever it is, the internet is used for that. And so the metaverse will surely be used for all of those things. And our view of the metaverse is that those things, just like they are, just like today, are going to be more valuable overall in our economy. Trillions of dollars invested in industry is going to be coming to the internet, essentially, because we can now replicate the things we do in real life there. But in order to do that, you need a different technology stack than the ones that are built primarily for entertainment. We've been looking at the metaverse and the simulation engines and the way we build content for it as essentially a gaming problem, which in many cases it will be. That's why we use game engines for this and game engine tools. But there's one fundamental difference between a video game and simulation of worlds that are for these other purposes, and that is that in a game world you actually don't need to match the real world. We don't. It's almost a negative for a game to be too closely linked to the physics of the real world. The worlds that we create for entertainment and for games, they're fantastical. There are superpowers there. There's magic. There's you don't have to go run for kilometers to get from your spawn point to where the action is. You know, they just teleport you or make you run a whole lot faster. Whereas if you're using these simulations to match things that we're going to build in the real world, if we're going to make digital twins so that we can have our factories and bridges and skyscrapers and all of these things accurately mirrored inside the virtual world, you're now going to need a different kind of engine, and you're going to need a different way of representing that data. We need one that actually matches the real world and the real world physics as closely as possible. That's a fundamentally different problem than just creating virtual worlds for entertainment purposes. This is where we're invested in, and this is what Omniverse is for. And the first thing you have to start with when you do this is describe all of the things that you're going to simulate. We need to have a way of building these virtual worlds and have the descriptions of them be as close as possible to the fidelity and accuracy of the things in the real world. So if you're building a factory or a car or a phone, the virtual representation and all the properties that we associate with it should match closely to those things. So we started when we decided that we needed to do this, that we needed to build virtual worlds that are accurate, and then a computational simulation stack that will allow us to do simulations that match reality as close as possible. So, well, first we need to be able to describe this stuff, and the best thing we found out there, luckily, that existed and had just been open source, was Pixar's universal scene description. Aaron's going to tell us a lot more about that. The other thing that was critical and immediate after that is, how do you describe how light interacts with matter in this universe? What we call materials in computer graphics. Materials is a much broader thing than just how things look, but it's a huge part of computer graphics is describing how light interacts with surfaces and volumes. And so it turned out that NVIDIA had already been working on a unique technology, a language to describe these interactions, and that's called MDL, Material Definition Language. And we also needed to describe and simulate accurately, but in real time or super real time, behavior inside this world, physics. And so we already had a lot of these technologies, most notably PhysX in-house. So we combine all of these things together to start creating a system that will allow us to build these rich, physically accurate virtual worlds and then go simulate them on big computers, on supercomputers. That's fundamentally what Omniverse is. Our take on it is different, I think, than you'll find most others who are talking about what the metaverse is. We believe that if you can build a real, reflection, an accurate reflection of the things in the real world, we're gonna unlock a bunch of superpowers. We're essentially gonna get teleportation. So if I can accurately mirror my factory that's on the other side of the earth on another continent and keep it up to date, real time in the virtual world, match exactly the state of my factory there, then anybody who has access to that virtual representation can essentially teleport there. You can move around in it just like a video game, maybe even put a VR headset on and go there, there's no difference between actually physically teleporting to the real factory or going to that virtual one, because the virtual one matches. It's identical. And if you can record all of that state over time and you save it, you essentially can rewind and go look at the state of your factory at any given point in time. And that's, we get another superpower. We get time travel into the past. You can both teleport and time travel into the past. And then if you can create a simulation that's really predictive for your thing, if you can simulate how the robots and conveyor belts and motors and everything in your factory is going to work, and predict some point in the future, maybe what's going to happen a minute or two from now, then you now gain time travel into the future. And even cooler than that is you can potentially, if you can do it fast enough, you can do these simulations super fast, much faster than real time, and you have enough compute power, you can run many simulations of different scenarios. You can remap, how your factory is working, change the speeds and feeds, change the layout of the lines or whatever it is, and explore many possible futures. And from there, pick the one you like the most and go implement that. So this is what we're trying to do here with Omniverse. We are essentially trying to create a teleportation and time travel device. And we're going to do that through computation. We believe that simulation of the real world is an extremely powerful tool that's essential for everything we need to do for the future of mankind, from solving climate change to minimizing our energy usage and carbon footprint of all the things that we're building and all of the machines we're building to build all those things. Optimizing all that is going to require this kind of simulation. And we can't really do it alone either. We can go do the parts that we're particularly good at, which is building computing stacks. We build computers and we build specialized software that maximizes those computers. But building all of the metaverse and all of the things inside it and all of the different applications and simulators, there's no one company that can do all of those things. So we built it in such a way that it invites everyone else to contribute. We connect to everyone else and go enhance what they're already doing. All right, with that, I think I've already rambled for quite a while here.
I didn't want to, first of all, as you were speaking, we're seeing comments roll in on both YouTube and Twitch saying how awesome it is to hear this perspective and to hear a company sharing in the way we're sharing. And you're preaching to the choir. And so I think this is perfect seg to Aaron and USD, which is, Omniverse wouldn't be what it is without USD, obviously, as you mentioned earlier. But while Aaron's speaking, I want to circle back with you towards the end, Rev, and you hop in at any time, of course. You have an open mic always. But I would like you to think about what's your advice to developers who are just getting started now, and how developers and artists, what should an artist do to prepare for this? What should a developer do? What do you think what would you recommend if it was your child who was getting started? Don't answer me yet. I think answer that towards the end, because I want to give Aaron a chance to talk about USD, and then we'll circle back with you.
One answer I was going to give is relevant actually to this.
Okay.
I think you should learn about USD. It's like the same question was asked in 1993, 1994. I was asked that, what should I do to prepare for the web and the internet? I said, well, go learn HTML and learn how to make a web page and fill this thing with content that's relevant. So understanding USD and what it is, that it's much more than a file format, I think is fundamental here. There's a lot of very advanced, powerful concepts that aren't immediately obvious with USD. So absorbing that, I think, is a critical thing. So it's good that Aaron is going to help with that right now.
Perfect. Thank you, Aaron. Yeah, looking forward to getting your perspective. And anyone who doesn't know what USD is, also, we have a Deep Learning Institute course on USD, totally free. Aaron, would you think is that a good place to get started as well after this stream?
Yeah, absolutely. But I also do want to let everyone know that we put USD View on Omniverse Launcher last week. So that is by far the easiest way to get up and running with USD. It's a fully turnkey solution where you just press a button, it downloads USD view, and then you press another button and it launches it for you. And Maddie wrote some great tutorials on it to augment the tutorials that I read at Pixar like 5 years ago or something like that hopefully still stand up.
And USD View runs on practically any computer. You don't need an RTX or a high-end GPU or any particular hardware requirements, which is a nice feature for learning.
Yeah, it has a nice Python interpreter in which you can play around with the APIs and learn them via tab complete and that kind of stuff. So that's definitely where I would recommend starting. The DLI stuff is great as well. I think we have Jupyter notebooks where you can play around without installing anything, which is great. But yeah, to echo what Rev said, I think, and what I wrote in the YouTube chat as well, I think this is really early days in the metaverse right now, and I think what I'm thinking that echoes what Rev said is that universal scene description is the right platform for all this sort of complex data modeling that we need to do in order to mirror what the virtual world is doing. We've learned about how to build software layers on top of USD to get real-time performance and things like that. And it's there's a long way to go there in terms of making USD more lightweight in order to be able to run in web browsers and things like that. But we've seen a lot of great work from other partners like Autodesk and things like that we're really looking forward to taking forward over the next year or so. And also, as Rev mentioned, a lot of our focus right now is expanding the data models that are already in USD to go beyond the media and entertainment space. So we announced partnerships with Siemens a month or so ago to build the industrial metaverse. And I like that term because it has a lot of it makes the future of the metaverse a little bit more concrete in terms of what we're building in terms of digital twins and virtual worlds. So virtual factories, virtual railways, highways, drives platforms for autonomous vehicle training, all that kind of stuff, where we know we need to go beyond what is representable in graphics for movies and games right now. And concretely, the three things that I presented in SIGGRAPH last week are: one is international language support, so that we can get more contributors from all around the world building with USD. To geospatial, so that we can represent large worlds as they actually sit on the surface of the Earth and potentially other planetary surfaces, as we invent games on other planets, or maybe we explore other planets, what have you. And third, the ability to stream the USD data into a runtime in a way that preserves the full ground truth of the real world in a virtual world in USD, but still allows you to distill it down to something that can run on any system, everything like supercomputers like OVX, like Rev mentioned, to handheld devices with whatever use cases you have.
Yeah,
So in terms of what's coming next, there's been a lot of talk recently about companies jumping on to help support and grow, evolve USD. What do people have to look forward to there, you think?
Like Red mentioned, there were quite a lot of speakers at the Metaverse course that he presented, and there are folks from Unity and Cesium, Epic, and I think this is just the beginning for a lot of great partnerships that we like. It was really great being at SIGGRAPH, talking to some of these people in person, so we can figure out together how we can work together on all these as I said, I'm definitely not a web GPU expert, definitely not a web assembly expert, so I'm really glad that we have partners in Autodesk to sort of help fill in some of the gaps there. We also have some folks on our team who came from that world as well, so I'm looking forward to taking on some of those problems. But yeah, this is definitely going to be a team effort all the way, and I actually think
open source announcements for Hydra render delegates, right?
Yeah,
both from DreamWorks and from Autodesk.
Yep.
That was a pretty big deal.
So Moonray and Aurora were announced as open source renderers that will, once we get our hands on them, we suspect they'll work out of the box with Omniverse kits as well. And if they don't, we'll get on it right
They're
away.
Hydra
Yeah,
render
yeah,
delegates.
yeah,
Hydra's the
yeah,
companion API to
yeah,
USD.
yeah.
So I have a question for you, Aaron. How are we contributing back to USD? You know, like the knowledge that we learn, how does that get back to USD, and how is it shared with everyone?
Yep. So we're often contributing back to Pixar's GitHub, and we're like the things that I mentioned in terms of UTF-8 for international character sets and geospatial. We've been writing some white papers that we hope to publish later this year, as well as some initial implementations that we want to share with the community to move towards standardizing them as part of the USD standard.
Awesome.
And we've done a lot already in the past. Python 3 bindings were done by us and integrated into, given back to the community. We've made a lot of changes that eventually ended up in the code base. We added last year we did the rigid body physics schema that was in partnership with Pixar and Apple. We co-developed it, and it's now a core part of the standard. And there's many more of these things coming, as Aaron mentioned.
Yeah, one I'm excited about is we'll be open sourcing later this year a GLTF plugin to USD, so which allows you to actually to basically treat GLTF just as it's any other USD layer. So you get all the power of USD composition while retaining your GLTF pipeline, and I think that's just the first step in a long journey towards harmonizing the GLTF and USD technologies and communities, I think.
Awesome. And Jan, thank you again for jumping on late in the day for you as well. How does this all tie into MDL? Do you want to tell Rev gave a good definition earlier? Is there anything you to add there, the definition, so people understand what it is? You just came off of a presentation, I think last week at SIGGRAPH.
Actually, I didn't present at SIGGRAPH. So my colleagues Lutz and Frankie, they presented there. So they had a talk on MDL. Yeah, so basically, how does it tie in? So Aaron talked about USD, which is a scene description, basically, and it has capabilities to express materials, but this is basically very open. Everybody can put in whatever he wants, and this is, of course, very bad if you want to share this between all kinds of different renderers, and that's where MDL comes into play. It also is basically physically based, so ties very well into the things that we had heard earlier, right? So you want to represent physical aspects in a reliable way, so that the virtual twins that they behave like in reality. This is true, of course, for physics, and this is, of course, also true for materials, and that's what we aim for basically with MDL, having a definition for materials that is agnostic of rendering technology. It should scale from the best simulation technologies down to a web browser or a preview window in an editor, and it should basically also be able to express things that are beyond what current rendering technology can do, right? So it should be able to express things that also future renderers can harvest and can go beyond what currently is possible in rendering solutions. So that's what MDL is about, yeah.
Key thing that maybe some of our audience haven't really wrapped their minds around is that we think of rendering mostly from an entertainment perspective, which is about creating beautiful images and ones that entertain us or give us delight, which is awesome. But 3D rendering is actually a simulation in and of itself. It's the simulation of how light interacts with matter. And for entertainment purposes, we're okay breaking the laws of physics. We often want to. If you might want to do a cartoon look, like Spider-Man Enter the Multiverse, it was awesome looking. but it used the renderer. It was 3D, but it's not physically accurate. What with MDL, what we created is something that was missing inside the set of technologies and standards that are out there to describe materials, in that it's hyper physically correct. It's constrained to only do things that obey the laws of physics. If you need rendering as a simulation, not to actually simulate how the thing that you're going to build is actually going to look, or potentially if you're going to use your rendering to give vision of a world to an AI so that it can learn how to see things, then you need to actually simulate that, and it has to obey the laws of physics. So MDL is the only system out there that allow you to describe materials that are physically constrained in this way. I think there's some questions that always come up about MDL versus other material systems like Material X. The truth is that no other system fills this particular niche. MDL is complementary to all of those other systems. It's not an either or thing. So Jan, maybe you could tell us a little bit about where MDL fits into the material stack, along with Material X and USD shade and that, because I think it's kind of confusing to a lot of people. Shaders, materials, all these things, like they seem to be describing the same thing, but they really aren't.
Yeah. And HLSL and OSL and all that stuff. So the first thing is that I want to touch on is that you said this. So there's more than rendering an image, and one of the things that we want to also do with MDL is basically not just do image generation, but other rendering things like sensor simulation, which would produce something completely different and basically not really useful for the human eye at all in the end, right? So we can describe this kind of stuff. We do this by abstracting from actually rendering algorithms. We basically have a set of distribution functions that just define how light reacts when it enters a volume, when it hits a surface, and this kind of stuff. We have color as an abstract data type that can represent potentially more than just RGB. I mean, humans are colorblind compared to even butterflies or chickens. So we can render something that also looks beautiful to a chicken or to a butterfly. It's things like that.
A mantis shrimp, right? Is it mantis shrimp? That one shrimp that could see 12 different.
I've heard of that.
Yeah. And so there this is one aspect. Then we also want to basically support the renderer. So with the Mdl Sdk that we also develop together with the language itself, we basically can generate code for renderers of all kinds of platforms. We can directly feed into a CPU renderer, a Vulkan renderer, HLSL-based renderer, and that's actually something we leverage in Omniverse, right? So you have the RTX renderer, the real-time mode, the path tracing mode, and also the eye-ray mode, and they are pretty different renderers from the algorithm perspective. So they all interpret the light interaction slightly different, and they have also pretty different architectures, right? So one is sometimes they run on Vulkan on Linux, sometimes they run on DirectX on Windows, and the eye-ray renderer is CUDA based or can just render on the CPU. That's all things that we can with MDL feed directly into. Yeah, and still we want to retain a lot of flexibility, so we have also a programmable language to do pattern generation, all the things that you typically need also in CAD applications like projectors, but also things like noise functions and of course texture lookups and volumes. That's basically the rough feature set. So if you want to have a more overview of what MDL is and what what it can do. We do have talks at GTC on demand. It's in general a good place to learn about all kinds of NVIDIA technologies. So there are Omniverse talks there, RTX talks, and also introductory talks on MDL and materials in Omniverse in general.
So
Cool.
awesome. Yeah,
Awesome. I
MDL
will-
is a game changer for textures. Oh my gosh. When
So
it
someone
first
just-
came out. Yeah. Go ahead.
Yeah, someone just asked. Let me see. Pink Pocket TV, is MDL more optimized than other shader languages, and how accurate is it?
Is it more optimized than other shader languages? It's
I
hard
think
to-
first off, you should explain that it's not a shading language. Shading
not a
languages
shading
are more
language, yes.
Turing complete, general programming languages where you can write any kind of program.
So
MDL is constrained to just describe materials.
yeah, so basically we have a programmable part for patterns, so for texturing, but for the light surface interaction, it's basically BSDFs, and the implementation of the BSDFs is up to the renderer. So it's partially at that point part of the renderer to optimize it. What MDL definitely is very focused on highly parallel architecture. So if you want to have a rendering algorithm run on something like a many core machine or a GPU, then basically MDL works very well. And apart from that,
But
shading
it
languages,
also emits the output of MDL is a program that could be
yes,
run on a CPU, or it could be a shader like HLSL, OSL, something else it can target. So it's a way to describe materials, but also target many different shading languages depending on your renderer and your system.
exactly.
Is that the distiller that does that? Is that what we announced?
The distiller is a bit different. So maybe getting back to what we announced about MDL at SIGGRAPH, right? So we have the Mdl Sdk for a few years. Actually, we developed MDL now for 10 years. And at some point we open sourced it, but we didn't open source all of it. So there were some things missing. Particularly, this was the full-featured GLSL backend, which we basically will open source immediately. This should be available any day now. The build is finished. And we open sourced the distiller. And the distiller is a special technology not for targeting different architectures, but for different levels of fidelity in the renderer. So if you have an MDL material, it can have many features that, for example, in game engines wouldn't work at the moment, or even in some production renderers are not available right now. So we needed a way to express materials or reduce materials down to a level that we can represent them in Unreal, and we do this in Omniverse. We have this Unreal connector that does that, and we use the distiller.
So today, if you want to create a material for your content that's going to be used with different renderers, you essentially have to do a material per renderer.
Exactly.
A renderer class, right? So what you would have for a real-time renderer, with OpenGL, Vulkan, or DirectX, will generally, because it has the real-time constraints, be a much simpler material model, a simpler shader than what you would have in a final frame renderer like Arnold or V-Ray or iRay and these types of renders that can spend more time. The distiller essentially is a way of downsampling the highest fidelity material down to something that these different classes of renderers that have a more limited material model can use.
Yeah. So we leverage that we have full knowledge of all the components that a material can have for light surface interaction. And the distiller is basically a graph traversal engine that allows you to do intelligent decisions on reducing the complexity of the material, independent of what this material actually implements. So we can have a very generalized mechanism to simplify any material that is written in MDL to the simplest possible target, losing some information, of course, but keeping as much as possible recognizable on the target.
I think it's also important to point out the reason we can even do that we have a chance to be able to automatically do that reduction, is because MDL is really constrained to only talking about materials. It's not an arbitrary shader language. You can't, there's no good way to take an arbitrary shader and reduce it down, because looking at a shader, that's just some program. You don't know what part of it is the patterns, what part of it is about the light interaction. You're going to have to extract that from the code magically somehow with some algorithms we haven't created yet. But because MDL is constrained to only describe things as patterns and light interactions, we have the opportunity to create a distiller, something unique with MDL that doesn't exist in any other system.
Cool. So going back to the metaverse, we have this opportunity to have this high fidelity source of truth in USD and MDL, and potentially deliver at some point to all sorts of devices that may have different computing power, different ways to represent.
It's always easier to go down
in
quality and fidelity than it is to go up. So in the past, when we created virtual worlds, it was primarily for entertainment purposes, for things like movies or games that you would ship. And so the content for those experiences would generally be designed for that moment in time, for the way it's going to be delivered. You didn't create content that was higher quality than you needed. You knew which renderer you're targeting, which game engine, on which console, but increasingly, and especially in all the other industries that now we're bringing computer graphics into, we're seeing the need to have content that's robust enough, that's high fidelity enough to be evergreen, so that we could use it for decades from now. If you're creating a digital twin of a nuclear power station, a reactor, you're going to operate that thing for 50 years, at least. And the content that you create today to describe it, you want that to still be useful 50 years from now. That means going to the maximum, even past what today's simulators and renderers could potentially do, as Jan was saying. With MDL, we can describe aspects of materials and the physics of it that actually no renderer today really does supports well, but eventually we will.
So also the amount of materials or content is, of course, in the industrial metaverse way bigger than if you just do something for entertainment purposes, right? So if you create a movie, then tons of artists create thousands of materials to basically represent the content of the movie. But if we go into the industrial metaverse, that's not much compared to the amount of materials that something like a apparel company goes through every year, right? So this is at some point something that where automatic processing becomes incredibly important. You can't really just do this with manpower anymore at some point. So if before, when you went from a movie to a game, you had artists just manually simplifying stuff, that's not going to work in that context at all.
Well, we have a few minutes left, and I promised I would get this question in for New Jersey Institute of Technology's Associate Professor Matthew Schwartz, who most people who are active on our forums and Discord will know very well because he's such a great contributor. He's actually working with a student right now on an extension that I think is going to blow people away. So his question, though, is this, which I think is very timely for this panel. Can the group elaborate on how to use pipeline for MDL with USD on physics simulation, or a set of verifiable material properties that will both look and act accurately in simulation and rendering?
I'm not sure what the question is exactly. It's like how
to use pipeline MDL with USD on physics simulation.
pipelined MDL.
Yeah, and Matt, if you're listening, you feel free to update your question on the live. So we have this channel on our Discord called Livestream, so people can ask questions on that channel. I try to watch that one. Matt, feel free to elaborate, but I think he's asking about general pipeline questions about MDL with USD for physics simulation. Or he says, or a set of verifiable material properties that will both look and act accurately in simulation and rendering. Not sure if that helps any.
Well, so Jan and the team have spent the past few years extending USD to include MDL materials. So that was like the first thing we did. So you need to be able to describe those materials. When you go assign MDL materials in any of our Omniverse apps and create to some USD prim and save that file out, the MDL assignments and information about all those properties are in there. So to make it physically accurate, that's the job of the MDL team and the people creating new materials with MDL. The MDL system constrains the things you can do to be physically correct to begin with. So
okay, he's clarifying now a little bit. So he says there are a bunch of materials in Omniverse. There is this V materials, etc. Physics sim has Poisson ratio, etc. When I assign a cloth material, it doesn't get included in simulation.
Okay, so yeah, this is a bigger topic, and one that we've been trying to wrangle for a while, and now we're making a concerted effort to solve. In computer graphics, generally, when we say materials, we actually have a very narrow view on what a material is. Usually, especially if you talk to rendering lighting people, they only think about the material properties, the physics properties for the visible light spectrum, essentially RGB, what humans can see, or what our typical cameras can see. But for simulation, we need to do a lot more. So for example, with our autonomous vehicle simulators and our robotics, we have LiDAR sensors, which is a different part of the electromagnetic spectrum. There's radar, and we even have sound. There's ultrasonics, which is wave-like phenomena. We're just now starting to get serious about potentially extending MDL to represent a lot of those things, particularly the electromagnetic spectrum. But past that, materials are even bigger than that, right? How cloth behaves, how wood behaves when you put stress on it and snaps, that's part of the material definition. And so we're exploring how to represent these kind of truly uber or super materials that have all of the information you would need to do all aspects of the simulation. So when you assign wood to something or metal, it not only looks correct in the visible light spectrum, but it looks correct to any sensor. And then it also behaves correctly when you apply forces to it in the ways that you would expect. It bends or breaks and snaps. This is going to be something that I think we're going to have to just keep advancing for decades. It's really, really hard stuff. But it's time now for us to have this expanded definition of a material in computer graphics, not limited to just the visible light spectrum.
So yeah, we are actually actively working on that. The problem is a bit that it works very well for light because the light interaction is a very well-defined and relatively small area compared to the whole complete world of physics, right? So we will expand this in the relatively near future. We need to figure out how far we go, but definitely for things like our own physics simulation, so rigid body dynamics and soft body dynamics, we will basically marry this into a bigger material definition that allows you then to automatically assign basically a a fabric and then get the correct behavior of the simulation. That's a goal we are actively working on. Like Ref said, to fully realize the full breadth of physics, that will certainly take a longer time. But for concentrated efforts for specific topics like the simulation aspects in Omniverse, this is something we are actively working on. Right now, it's not there.
I mean, eventually you might even have like electrical conductivity, magnetism, all these other things defined in there too. We just have to do it one step at a time. Pick the things that are most relevant for the problems we have today.
Yeah.
But create a system where we can expand it, keep extending it, and adding more of that information.
All right. And so to circle back on the question I asked Rev to think about a little bit, besides learning about USD, what's your advice for developers just getting started, getting excited about, creating content for Metaverse, whether it's a artist creator or it's a developer? Where should they start?
I think everyone, if you believe that the metaverse is going to be an important part of everything that we do, and the key thing about technology in the metaverse is computer graphics, which is 3D computer graphics is essentially world simulation. It's this niche branch of computer science where we simulate worlds and all aspects of it till eventually we produce an image from it inside that world. I think if you believe that, then you should at least understand some of the fundamentals of computer graphics. Just like in elementary school, you start learning the basics of English or whatever language you're being taught in. You have to learn grammar. You learn basic arithmetic. You learn basics of various sciences and social studies and whatnot. I think computer graphics is now going to be one of those things that everybody should have some literacy in, because it's going to be everywhere around us. Computer science in general is like that. I think everybody should know a little bit. Even if you're not going to be a programmer, you should understand, like, at least write a computer program a few times so that you can understand the things you're interacting with, how they work a little bit. Not everybody becomes a mathematician, but it's pretty useful to understand algebra. Even if you never use it in your day, like, you want to get that. So I'd say go learn some of the basics of computer graphics.
That's great advice. Yeah, and it's funny, very timely, because a couple people have told me, at least two, maybe more actually, in the last few days. I've been checking on people with their contest submissions, how things are going. And I've heard, again, more than once that someone said they have never coded before. They have an art background or designer background, and they took the opportunity to participate in this Extend Omniverse contest, which is in progress now. And they did their first coding for the first time. And they're very...
really great to hear. That warms my heart, because our goal with Omniverse from the very start has been to help democratize the creation of these virtual worlds and their simulations. So everything we're doing is driving towards that. And as we make advances in artificial intelligence, we're going to more and more integrate those technologies into Omniverse to help assist people in creating these worlds, even if they don't have all of the skills. Because today it's just so hard to build virtual worlds, especially dynamic ones with behavior. You can spend decades just honing one particular skill in a game studio or VFX studio, just texture painting or modeling or animation, character animation. They're all specialties. We need AI to make it so everyone can create. And so you're going to see that more and more, and it's great to hear that it's already starting to happen.
That's awesome. Well, on that note, I can't thank everybody enough for coming on today's live stream. I can't thank especially the people who are watching, asking these great questions. And we've got a lot of more positive comments from the discussion than we did questions. But if we missed your question, I see the couple that are hanging out there. A few of us are going to hang out in the community voice chat channel following the stream. And I would like to also give a very special thanks to Edward McEvenu, who spent last week at SIGGRAPH at the ASUS booth showing off Omniverse workflows with Autodesk tools. He did a fantastic job. We got a nice note from ASUS this morning. Wow, Edward was fantastic. He really helped explain things and let people really understand how Omniverse can impact their workflow with all these other tools that are out there that people know and love. So thank you, Edward, and thank you, ASUS, for that opportunity. If anyone got to go to SIGGRAPH, I hope you had a great time. GTC is coming up. So nvidia.com/GTC will take you right to the registration page. It is free. And there's lots of Omniverse specific sessions. I think there's at least 7 that I saw that looked really, really good. So we're going to add events for each one of those on Discord server. So another plug for Discord. Come on Discord. You can find out what's coming up next by looking at events. Maddie's on there. He has office hours regularly. So if you are thinking about coding, Maddie and the others in the team will hop in and help you. Now's a great time. The contest ends on Friday. So you can use Extend Omniverse channel if you want to talk about your submission. Still plenty of time to do something. So thank you very much. Thank you, Wendy. Congratulations on episode 50.
Yay!
Now finished. I look forward to the next 50
fun.
with you, Wendy and Maddie.
Me too.
Thank you, everybody.
Love you guys.
Thank you.
Bye.
Thank you.